Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the attributes and key features for quadratic functions. Now, this is part one of a two-part lesson. So, before we start, let's look at a little definition for quadratic functions. A quadratic function is a function of the form f of x is equal to x squared plus bx plus c. The important part of this quadratic function is this power of 2 on the x in our first term. So a quadratic function is always going to have x raised to the power of 2, or a squared component. Now, the graph of a quadratic function is a U-shaped graph called a parabola. So in this example, in the box below the definition, it says circle the quadratic functions. Now, I'd like you to start with the graphs first. So pause the video and circle all of the graphs shown below that you think might be a quadratic function. All right, welcome back. Let's see how you did. Here's the ones I circled. Here we have a U-shaped graph that opens upward. Here we had a U-shaped graph that opens downward. Another U-shaped graph opens downward, and then we had a U-shaped graph right here. So these are all examples of linear functions. They're U-shaped graphs, which we call parabolas. Now, let's look at our equations. Pause the video and circle all of the equations that you think might be quadratic functions. All right, welcome back. Let's see how you did. All right, I circled this first function, f of x equals x squared minus 3x plus 2, because it had that power of 2 on the x squared. Okay. I also circled this function here because it had a power of 2. I circled this function because of the power of 2. And there's one more I also circled that you might not have realized was a quadratic function, and that was this function. This one's a little tricky because you don't see a power of 2, but this function can be rewritten as f of x equals x squared minus x minus 6 if you multiply out the x minus 3 and the x plus 2. So that one was a little tricky, but it was a quadratic function. All right, now in example 1, we're going to complete each table and sketch the graph of the quadratic function and then identify the values of a, b, and c. So in this example, what I want you to see is how we can use a table of values to represent, to then represent that function as a graph. And then I also want you to get familiar with identifying what is the value of A, what is the value of B, and what is the value of C, because those values tell us something about how the graph looks. Okay, so let's start with problem A. We're going to create a table of value on the graphing calculator. I'm using Desmos, but you can use any graphing calculator that you want to do this. So our function rule here is x squared plus 2x minus 3. All right, now I'm going to go to my settings, this little gear here, and click on the table. And so -3 is not shown in the table, so I can scroll down here. I want to go down to the bottom of the table and type in -3, and that gives me a value of 0. Whoops, I wanted a pen here. 0. And then -2, -3, -1, -4, 0, -3, and 1 comma 0. So what I'm going to do now is I'm going to plot these points. 1, 2, negative 3, 0 would be right here. Negative 2, negative 3. Negative 1, negative 4. 0, negative 3. And 1, 0. Now, because this is a quadratic function, we want to connect these in a smooth U-shaped graph. So as carefully as possible, I'll try to connect them with a U-shape. Okay. And there's the graph of our parabola for f of x equals x squared plus 2x minus 3. Now, in this problem, the value of a is our coefficient of x squared. So if we look at the x squared, notice that our coefficient of x squared was a positive 1. Our coefficient of our b is the coefficient of x, which in this case is positive 2. And our c value is the constant term. In other words, the term without a variable. So in this problem, our c value is negative 3. All right, problem B. We have the function x squared minus 1. So let me just edit our previous example, change it to x squared minus 1. And our, let's see, let's get rid of the previous table. Hit the gear button, press table. So negative 2, positive 3, negative 1, 0. Whoops. There we go. 0, negative 1, 1, 0, and 2, 3. Now let's plot these points for this function. So negative 2, positive 3, negative 1, comma 0, 0, negative 1, 1, 0, and 2, 3. Now we've got our main points of our parabola, so I'm just going to connect them with a smooth U-shaped graph. And then it wants me to list the values of a, b, and c. So in this problem, the value of a is your coefficient of x squared. So just like the last problem, it is a coefficient of positive 1. Our coefficient of b, our b term, is the coefficient of x. But in this problem, we don't have an x term. In other words, you could have rewritten this problem as x squared plus 0x minus 1. We do not have an x term. So we would say in this problem, our coefficient of b is 0. Now, our coefficient of c is our constant term. In other words, the term without a variable. So our value of c is negative 1. All right, problem C. We have f of x equals negative x squared plus 2. So let me just change this. Oh, we want to make it negative x squared. So let me move over here. Make that negative. All right, so negative x squared plus 2. Press the gear button. Make a table. So when x is negative 2, the y value is negative 2. When x is negative 1, the y value is positive 1. When x is 0, the y value is 2. When x is 1, the y value is 1. And when x is 2, the y value is negative 2. So let's plot those points. Negative 2, negative 2. Negative 1, positive 1. 0, 2. 1, 1. And 2, negative 2. So we'll make our U-shaped graph. All right, now they want us to identify the value of a, b, and c. So in this problem, remember a is the coefficient of x squared. So that in this problem would be -1. All right, our value of b, we do not have an x term, so we're going to say our value of b is 0 again. And our value of c is +2. All right, now in the last box, they want us to compare the a values in a through c, summarize how the value of a affects how the parabola opens. So in examples a and b, our value of a was +1, +1. And notice that both of the graphs opened upward. But in problem C, our value of a was -1, and the graph opened down. So when you had a positive a value, the graph opens upward. When we had a negative a value, the graph opens down. Now, they also want to know what special point on the graph does C represent. So let's look at our C values. In problem A, it said C was -3. So if you look on the table, here we have 0, -3. That would be right here. In problem B, our C value was -1, and that occurred right here. And here is our 0, -1 on the graph. In problem C, our C value was +2. That occurred right here. And that occurred right here. So notice on each graph, the value of C is always where the function touches the y-axis. So the C value is always your y-intercept. The value of C is always going to be your y-intercept. All right, let's look at our next example. Graphs of quadratic functions have several key features. Use the definitions below to label each attribute on the parabola at right. Now, the vertex of a quadratic function is also called the turning point of the parabola. The turning point of the parabola. So if you look at the parabola shown, notice that it turns around at this point right here. So let's label that as our vertex. Now, the maximum or minimum of the parabola is the y value of the vertex. So this particular parabola has a minimum value of -4. A minimum value of -4. The zeros of the quadratic function are the points where the parabola crosses the x-axis. They're also called the x-intercepts or the roots of the parabola. So I'm going to label this with a 0. We have a 0 here. We have another 0 here. Okay, those are the zeros of the quadratic function, where the function touches the x-axis. The y-intercept is the coordinate where the parabola crosses the y-axis. So in this parabola shown above, I'll put a dot right here. This is where it touches the y-axis. And so we would label that as our y-intercept. So these are some terms you need to be very familiar with when you're dealing with parabolas. Luckily for you, a lot of you have already heard these terms when you're dealing with linear functions. So most of these terms, except for vertex and minimum, you used when you were graphing lines. Now in example 2, it says identify the key attributes for the quadratic function shown below. So remember, the vertex is our turning point. So I'm going to put a dot on the turning point of this graph. All right. And we write the vertex as an ordered pair. So it's going to be something, comma something. Okay, so for the x, we're not going left or right. So that's going to be a value of 0. But for the y, 1, 2, 3, 4, we're moving up 4 units. So our vertex on this graph, or our turning point, is 0, comma 4. Now, the maximum value, so you know what? Let's go ahead and label that. This is our vertex. But the vertex always tells you your max or min. So this parabola has a maximum value of 1, 2, 3, 4. So max of 4. Positive 4. Okay. The zeros are your x-intercepts. So this function has 2 zeros. One at -2 and one at +2. So I'm going to say x equals -2, x equals +2. And now in this function, something kind of unique happens here because the y-intercept, where it touches the y-axis, also happens to be the vertex. So the y-intercept is 0, 4. So I'm going to label that over here. Now that will not always happen. They will not always be the same ordered pair. But in this particular happen, the y-intercept also happened to be the vertex and the maximum of the function. All right. Let's look at our next graph. All right. Now the next graph, the parabola opens upwards. And so the turning point occurs right here. Now be very careful because this graph is scaled by 2's. So our vertex here would be -4, 0. Now, because the graph opens upward, we don't have a maximum value. The maximum value goes to infinity, positive infinity. So the maximum value here, or excuse me, the minimum value is going to be the y value of your vertex. It has a minimum value of 0. Now, this parabola only has 1 0. It only touches the x-axis one time at -4, 0. Now, it also has a y-intercept. So look carefully at where this graph touches the y-axis. Pause the video and write down what you think is the y-intercept. All right, welcome back. Let's see how you did. So I said the y-intercept occurs right here. And it occurs at 0, +16. Now, before we move on, let me label some of these points right here. This is a vertex that has a minimum of 0, and it's also the only 0 of the function. So in this problem, our vertex was also our 0. All right, example 3. The graph of f of x equals x squared minus 2x minus 3 is shown. Use the graph to determine whether each statement is true or false. All right, pause. Oh, excuse me. If false, rewrite the statement to make it correct. Pause the video and try example 3 on your own. All right, welcome back. Let's see how you did. So in problem A, it says true or false. F of x has a y-intercept of -3, 0. So let me find the y-intercept. It is right here. Now that's on my y-axis. So if I labeled it, it would be 0, -3. And I'm going to go ahead and put y-intercept. So was the y-intercept -3, 0? Nope, that was false. So they want us to correct it. So the y-intercept is 0, -3. So they were trying to trick you on that one. Hopefully you did not fall for it. All right. Statement 2. The vertex of f of x is 1, -4. All right, so let me draw on the vertex. That's my turning point. So there's my vertex. So I'm going right 1, 1, 2, 3, 4, and down 4. Yes, that one statement was true. So no correction needed. All right. The 0 of the function is -3. Well, hopefully you put false because this function has a 0 here. Let's label it. And a 0 here. There are actually 2 zeros of this function. So I'm going to put the zeros are x equals -1 and x equals +3. So correct the statement. And that concludes today's lesson, Attributes of Quadratic Functions, Part 1.